A customer came to me with 4 of these wheels. They would not fit. He bought them new and they were supposed to fit, but they did not. Problem is the center hole is too small, and he figured out that their 8 thousandths too small. Should be 2.250. I made a setup on the milling machine. I want to show you how I did that, why I did the setup that I have here. I just finished one, and as I go through the process of putting another one up there, I'm going to explain everything to you. This is a 2-axis CNC mill. I wrote a simple program there. It shows a picture of it. Basically, there's a hole in the center, and there's a circle. Well, the way that program is written, there's just a center to move me to center, to the approximate center initially. And I wrote a program for a circle frame with a 1 1/8 radius. I defined a cutter diameter, and that's the process I'm using to machine this hole. And I'm doing a circle with an end mill because I have a CNC, and I'm climb milling. I'm going this way. There's a boring bar set that you can buy, and you could use it, but it'll drive you nuts. I never use it. It's a piece of junk in my opinion. It chatters. It's about useless. There's a real old school way of doing this where you put a boring bar in and you put a carbide tool bit in it, typical lathe tool ground for this, and what you do is you just run this down through the hole, but you got to tap your tool out. You loosen the screw and tap it out with a hammer, and it's a trick of the trade that takes years to get the knack of how to do it, and it's extremely accurate. It's a very good way of doing it. It's the best way of doing it, actually. But here I'm doing the second best way, which is using this end mill. And I made a setup here. I have these 6 blocks that I use for various setups, and turn them in such a way to give me the right height. And I created a triangle of support here. I have 2 bolts fairly precisely located and anchored solid to the table. They're the right spacing for 2 holes in the wheel. And I have these blocks set up, one on each side. Kind of gives me a secondary locating, something to bank against, and as I put the wheel on. Now, you might be wondering why I don't just bolt this down onto the table. I could bolt this face down to the table. Well, I can't guarantee that this face here is exactly perpendicular to this face here. This is the registration face on the car, on the vehicle, so that's where I want to be locating. And I'll show you how I do this. Take the wheel and I bank up against the big angle blocks. Drop it down over the bolts. I made these, made 2 of them. They have a taper on it that matches the inside of the hole. I pushed Play-Doh down into the one of the holes, pulled it back up out. I was able to use the Play-Doh to determine what the angle was, within reason. So, anyhow, I bolt this on. Now, I got 4 of these, so I went fairly reasonable repeatability. And I don't have to over tighten it because it's a good solid mount. And the worst thing that could happen to me is I over tighten this and hear it crack. And then I'm going to be really embarrassed when I tell my customer. So I'm going to move to position that I call the first program event, which is a hole, which moves me to this location here. Now, theoretically, that should be on center right now, but there's no guarantee that everything's exactly the same. So I'm going to check every one for 0. This is called an indicall, or a universal indicator holder that mounts on milling machines on this surface right here. I have it in neutral right now. I'm coming down, dropping my spindle, moving my indicator into position where I'm touching just a little bit, spinning around. Wow, the repeatability is great. I'm off in this direction. I'm off about 2 thousandths. Just gonna leave it. I think it's accurate enough. Now, I'm going to put my end mill in the R8 collet. Oh, maybe I call it out. I have a power drawbar. Works real nice. All right, I'm going to go to the second event. Put the spindle in gear. CNC program is going to walk around there. Starts right here, it's going to walk all the way around and finish. And when I bring the end mill up out of there, I'll check the hole, it should be done. I got a feed rate of 3.0, which is 3 inches per minute. Around the 2-inch hole, it's about 6.5 inches, so it's going to take about 2 minutes to go around. Got a nice sharp end mill, take a nice cut. I had to watch so I didn't get my bolts too high here, because they'll hit. Came to the end of the cut, so I'm going to raise the spindle, shut it off. Got some chips in the hole I need to gently blow out. This is an inside micrometer. I'm going to use it to check the hole size. I could read the size right off of here if these are accurate, but typically they're not, and you have to double check them. So what you do is you put it in here and you kind of rock it across the micrometer until you just feel it touching. But first you got to set this. Got to reach in here and gently turn and rock. A little tricky. Takes practice. Felt pretty good there. All right, so I got 2.252, which is good. I think it should be a little bigger than 2.250. We'll take the cutter out. I'm going to jog way over there so I get some clearance to be able to take that wheel off. Might check it again just to be sure. Once I take it out of there, it's a little bit of a pain to set it back up again. This is a typical inside micrometer. checking and confirming the size with an outside micrometer. I got the same number, about the same number. Second time. Here's that inside micrometer set. It's an old Starrett set. Here's another set. It's a little smaller. This starts off at 2 inches. This one starts off at 1.5 inches, and keep putting these adapters on here. This is just an extension handle to be able to reach in a hole. Going to go back to the center position. Put my indicator back on. Put a neutral. Bring the indicator down. I'm going to set 0, new zeros. The end mill back in. A nice little power drawbar. Spindle on. Starting at my circle vent. If you are interested in machining and fabricating, subscribe to this YouTube channel, Ken's Machine Shop. I have over 50 years experience, and I plan to make many more videos to help save this dying trade. Thanks for watching.